Welcome, Astrid.
Vielen Dank für die einführenden Worte.
Thank you so much for this kind introduction, ladies and gentlemen. I believe that all of us here united in this room, we all agree on the fact that the efficiency of the use of daylight and other factors of well-being are absolutely key in housing. But what's going to be the way to take this knowledge into the public? How can we influence policymakers? How can we raise awareness for this topic? So this, in fact, is a question we talked about yesterday also. And I am happy today to speak to you about interdisciplinary research concepts, just to get there precisely, to get from energy efficiency towards well-being in housing. Talking about housing quality, we've been observing throughout history, and I can't work the clicker here. Can I get some help, please? Right, so thanks. Okay, so in history we've seen a dramatic change for people living well before us. Housing was all about protecting oneself against a hostile environment, whereas today, using high technology equipment, we try to restore the access to important environmental factors back into our dwellings, be it daylight or fresh air. So, well-being and good living is a major health factor. This is something the World Health Organization has also stated, and it has underlined the importance of our environment. So, modern man spends 90% of his lifetime in enclosed surroundings. So this means that interior climate, interior surroundings play a major role. But having said that, there are more environmental factors to consider. Climate change, in fact, is something that the public is aware of now. And with our existing buildings, we've got a major lever to use in order to take measures in this respect, because our existing buildings, our existing housing stock are absolutely key for energy consumption, and they're also responsible for CO2 emissions. So political awareness has already matured to the point of having introduced corresponding legislation. Still, energy efficiency is just one of the building blocks related to good living. We also want to have good soundproofing. We want environmentally friendly and healthy building components to be used. We need fresh air. We want housing to be affordable. We want thermal comfort to be present in our homes. Safety is becoming more and more important, and security, and also daylight supply. So all these factors come into play as we look at our well-being and good living, and they have an impact on our health and on our overall performance in life. So this is the content of our initiative, Good Living. You can already tell from the logo that man is at the center of this initiative, and this is what it's all about. That's the key topic. This initiative is made up of company partners, partners from the industry, but also research partners, a number of universities, and also Fraunhofer Alliance for Building as a research partner. We deliver robust scientific foundation in order to be able to approach policymakers and in order to be able to try to align political focus on human needs. And let's speak about acceptance for retrofitting measures in buildings. That too depends mainly on improving our homes with regard to comfort and health, which is why this initiative I'm presenting is aiming to set new standards for good living and would like to see those implemented in political terms also. Now, what's the way to implement good living concepts? It's a very complex topic because we live in an era of urbanization, and on this slide you can already see how many mega trends are influencing our lives at this moment in time, and they're also influencing the way we build buildings, our whole approach to construction. You can see that the lack of living space is a key aspect with regard to urbanization, and there's a direct conflict of interests with the topic of daylighting, because we need to densify our cities, and we can see social change, we can see climate change, we can see an increase in energy consumption and an increase in transport and traffic. Our infrastructure is in need of refurbishment also. So there is a whole series of issues which are all important and which we all need to consider in housing and construction. So this high level of complexity does require us to take an interdisciplinary approach and to collaborate. We need different industries coming together. And let's just think of information and communication technologies, which currently is penetrating all subject matters and all disciplines. So the fact that we have to interact between research disciplines is something that Fraunhofer is aware of. Fraunhofer Society for Applied Research includes 69 research institutions all over Germany. I would like to present to you these institutes within Fraunhofer, which collaborate in the Fraunhofer Alliance. It's 24 of them. Fraunhofer Building Innovation Alliance is one of them, which you can see down on the left-hand side, which is a central contact point within Fraunhofer on building research. And this is where interdisciplinary collaboration is pushed. So the Alliance, the Building Alliance has 14 Fraunhofer institutes as partners, which are related to building, just like the Fraunhofer Institute of Building Physics or the Institute of Solar Energy Systems or Wood and Timber Research. But here you can also see from our partners that we've got chemical technology there and microelectronics also. So we can take a look at construction and building from different angles in this partnership. So these are our fields of research and development, 8 fields of research which deal with current megatrends. You can already see with the third field of research, which is comfort and health, that precisely this topic is absolutely key for us. I would like to show you a brief example from practical implementation from Fraunhofer's construction research. It's a project consortium. Thank you. It's a project consortium led by the Fraunhofer Institute of Building Physics. It was financed by the German Environmental Foundation. You can see that there's a number of companies that collaborate on this project. This is about applied research. Next to the Fraunhofer Institute for Building Physics, Rosenheim University was involved. With the industry partners, I would like to underline Dial, which is a company that provided the software we needed in the project. This project was about transparent and translucent facade elements. So non-translucency factors were supposed to be calculated, so this way a hands-on tool was supposed to be developed. As said, the software was provided by Dial. Dialux Evo was used in the course of the project. More than 600,000 users have already registered worldwide, and there's a database that can be used which uses different facade systems and their behavior in different daylight contexts. The part of the Fraunhofer Institute of Building Physics in this was to improve lighting engineering in the facade system, and also to apply the corresponding measuring technologies and to develop some algorithms. To that end, the Fraunhofer Institute of Building Physics uses a gonio-photometer. I cannot go into the details of this right now, but here in the audience we've got Mr. Jan de Boer. He's the project lead at Fraunhofer. Where are you, Mr. de Boer? There you are. So if you have any question on the subject matter, please turn to him. For all other questions, I'll be happy to take them. So with that, I would like to thank you for your kind attention.